Hello everyone, my name is Mr. Amoyavi and I am one of your grade 12 advanced maths teachers. In our last lesson, we talked about the average gradient and we did a brief explanation of what calculus is. In today's lesson, we'll be talking about differentiation from first principles. All right, as you can see, I've got a diagram already, which is similar to the one that we saw in our last lesson. I've got a graph of this function, a quadratic function, which is y equals x squared. And then I also have that secant that we saw. Okay, so we are going to define the gradient of a curve at a point in this lesson, but that would be also called the differentiation. All right, so given this curve here, we said we can't really calculate the gradient of this curve, which will be consistent throughout. But we can calculate a gradient of this curve at a point. So this is how we are going to define this. Given this equation, y equals x squared, and taking this point here, point Q is on the curve, along the curve. So if I have to look at this secant here, and I have to move this to this point and this point and this point, and this point here is point P with the coordinate xy. So this secant, if you move through, it becomes what they call a tangent. A tangent is a straight line that passes through a point on a curve. So this line, this secant now, if you move through these points here that I have stated here, it will become a tangent. So we are also going to determine the gradient of this tangent. That will be also the gradient of this curve at this point of tangency. Right, so given this equation, which is a quadratic function, this point Q is along or is on the curve here, so it must satisfy this equation if you substitute. So for y, we're now going to replace with y plus delta y. Okay, take note of this notation here. Delta y means a small increase or a change in y. So y now is going to be replaced with y plus delta y equals x now would be replaced with x plus delta x. But don't forget your 2 there. Now if you were to look at the right side, it is an algebraic expression known as a binomial expansion. So you know how to learn, you know how to expand this binomial expansion. So it will be like x plus delta x multiplied by x plus delta x. Right, so on the right side we have delta y plus y. So if I have to fully expand and collect like terms here, I will get y plus delta y equals x squared plus 2x delta x plus delta x squared. Right, I know that this y here is representing this x squared, so I can replace this y with x squared. So I will have delta y equals x squared plus 2x delta x plus delta x squared. Now if we have to move this x squared to this side, it is positive, so eventually it becomes a minus. Therefore, it will cancel out. And so on the right side, we will be left with delta y equals 2x delta x plus delta x squared. Now, from what we have learned in our previous lesson, we said the gradient of the line secant PQ is equal to the change in y divided by change in x. Right, so this is y, so we just have to divide this expression by delta x. Right, so we have 2x delta x plus delta x squared all divided by delta x. Now we see that in the numerator, the highest common factor is delta x. So we can take the delta x outside and say delta x divided 2x delta x will be just 2x plus delta x divided this one will be delta x, all divided by delta x. Now we see that delta x and delta x can cancel out because they are common factors. Right, so we are left with 2x plus delta x. Now we are going to apply what they call a limit. So if I have to apply a limit, because if this number here, delta x, is a small increment, so as we move through the points here, you'll find that x will approach, delta x will approach 0 and it will approach this number, right, x. So we will say, therefore, we are going to introduce another notation for the derivative function or derived function, which is dy over dx of this function will be same as taking the limit of this function. Limit of this function 2x plus delta x as delta x approaches 0, and if delta x is not going to be equal to 0, then we're going to take the limit and say this will eventually approach 0 and it will become insignificant. It will be like 0, so we are only going to be left with this expression, 2x. Right, this 2x is the gradient of this curve at this point. Or we can say it is the derivative of this function. And also we can also say that this function here represents the gradient of this tangent here. So basically what we have learned in this lesson is how to find a derived function using the process of differentiation, but specifically the first principles method. So what we have done is we have defined this point here, point Q, using this process here to find the gradient of this secant, which is PQ, and we are going to take the limit. Again, this part here is the gradient of, or gradient expression for the gradient, secant PQ, right? So the gradient of this function at this point P is given by 2x. Right, so this is basically the whole process of differentiation using the first principles method. In our next lesson, we'll talk about the rule for differentiation. Thank you, everyone.